Good day. Okay, let's start the DH frame rules in our example here in a cylindrical manipulator. Okay, so the first rule is that the z-axis must be the axis of rotation for a revolute or twisting, or the direction of translation for a prismatic joint. So let's choose light blue and line arrow. Okay, so this the first joint is a revolute joint, and this is the axis of rotation. Okay, next, the next joint is a prismatic joint. Okay, so the direction of translation based from the projected square is here. Okay, next. For our third joint, the direction of translation, because it's a prismatic, based on the projected square, is to the right side. Okay. And lastly, we need to have a, a, a z-axis for the end effector. But the end effector is not a joint, unlike the first three joints. Okay. So the common practice here for end effector is to just follow the z-axis, the direction of the z-axis before it. So the direction of the z-axis before it is pointing at the right. Okay. So these are our z-axis. So based from the preliminary rules, let's make the z-axis easy to see. So to make z-axis easy to see, I will make the arrow, or I'll make the arrows thick. Okay, this one, another one. Oh, sorry, and another one. Then I need to label it with Z with a number starting from 0. Okay, so the count of frames starts with 0. Okay, not from 1. So the rule here is the counting of frames starts from n minus 1. Okay, unlike the links and the joint variables, the frames will start from n minus 1. So if n is equals to 1, so the first frame is equals to 0. Okay, next. So this is frame 0. This is frame 1. Next is frame 2. And lastly, frame 3. Okay. Next, rule 2. So rule 2 and rule 3 is for the x-axis. Okay. So I will make the color of my arrows color red and thick to make x-axis easy to see. So rule 2, the x-axis must be perpendicular both to its own z-axis and the z-axis of the frame before it. Okay? So at our first joint, at our first frame, we don't have z-axis before it because our first z-axis is z sub 0. There's no such thing as z negative 1. Because of this, we can decide to either put or point x-axis to the right side or to the left side or to the back or to the front. Okay, we can choose freely as long as the x-axis is perpendicular to its z-axis, to its own frame. Okay, so based on experience, the best position for the x-axis at the base is pointing to the right. Okay, so let's name this x-axis x sub 0. Okay, next, for our joint 2 or sorry, for our frame 1, no, it is no more called joint 2 because we already have an origin, okay, for the frame 1. So we are not calling this joint 2 anymore. We are calling now this part as frame 1. Okay. So for frame 1, okay, because this is the second frame, we will look at the first frame. So we have here a Z0 as the frame before, the frame of X sub 1, and Z sub 1 as the Z axis at the same frame with X sub 1. So our our choice is point it to the right or left, back or front. Okay, as long as it is perpendicular to both 0 and z1. So based on experience, it is easier to compute this for our next lesson if the x-axis are at the same is at the same row, or at they are facing to each other. Okay, so I will also point this to the right. Okay, and I will label it as x sub 1. Next, for our x sub 2, okay, let's go to the origin. Okay, so we will look at the z-axis at the x sub 2's own frame, which is z sub 2, and the z-axis before the x sub 2's frame. So z sub 1 is pointing upward while z sub 2 is pointing at the right side. So our only choices are at the front or at the back. So I will put it at the front for me to see it properly, the x sub 2 axis. So I will label it as x sub 2. Okay. Lastly, for the end effector, we will follow rule 2. Okay. The rule 2 states that the x-axis must be perpendicular both to its own z-axis. So our z-axis, okay, here at the own frame of x sub 2 of x sub 3 is z sub 3. Then the z-axis before it is z sub 2. So z sub 2 and z sub 3 are both pointing at the same direction. So our only choices are front or back. So as I said earlier, based on my experience, it is better if your x-axis are pointing are pointing at the same directions or facing to each other. Okay, so I will choose to the front, just like x sub 2. So this is x sub 3. Okay, so this is for the rule 2. Okay, next is rule 3. Rule 3 is also about x-axis. So each x-axis must intersect the z-axis of the frame before it. So what does it mean? X-axis, okay, the x-axis must intersect the z-axis of the frame before it. For example, is x sub 1. X sub 1 must intersect with z sub 0. Okay, so before we go to z sub 0 and x sub 1, let's go first to x sub 0 because it's the first x-axis. Okay, at frame 0. So there is no z-axis before the frame of x sub 0. So let's leave the x sub 0 on its place. Okay? Now let's go to x sub 1. So according to rule 3, z0 or x sub 1 must intersect to the z-axis of the frame before it. So the frame before it is z sub 0. Okay? So how will you make x sub 1 intersects with z sub 0? Okay, class. So be reminded, class, that the directions you chose for your axis are the positive directions, while the opposite side of your chosen axis will be considered as negative. So what does it mean? Okay, so everything everything at the right is x sub 1. Okay, everything at the right is x sub 1. As well as to the left, this is also x sub 1. But the x sub 1 here is negative. Okay, this is negative to the left. X sub 1 to the right is positive because this is where you pointed your axis. Okay, the same with other axes. Z sub 0, everything upward is positive, and Z sub 0. Everything downward is also Z sub 0 but negative because you don't choose Z sub 0 to point downward. Okay? So it means Z sub 0 extended is Z sub 0. Okay, positive Z sub 0. While X sub 1 extended to the right is positive, extended to the left is negative. Therefore, we can extend the x-axis and z-axis to see if they are intersecting with each other. Okay? So the only x-axis or z-axis you will what do you call this? You will mm, extend are the x-axis needed for rule 3. Okay? The x-axis needed for rule 3 in frame 1 is x sub 1 and z sub 0. So please be reminded with that, or please remember that. Okay? Don't don't extend z sub 1 downward to intersect with x sub 0. That's not what rule number 3 means. Okay? What rule number 3 means is the succeeding or the latest x-axis must intersect to the last, wait, I think it's wrong. Sorry, current the current x-axis must intersect with the late z-axis. Okay? So this is what you will do. You will try to extend z sub 0. Then see if z sub 0 is intersecting with x-axis, with x sub 1. Okay? So everything here is x-axis. Remember that. So because everything here is x sub 1 axis, then z sub 0 is intersecting with x sub 1. Okay? So it also means that your x sub 1 axis complies to rule 3. Okay? If it doesn't comply, we will do something for the compliance. Okay? So if it already complies, let's proceed to the next frame. So the next frame has x sub 2 here. Okay, and the z-axis before it is z sub 1. We will try to extend z sub 1 and look if it will intersect with x sub 2. So it will intersect with x sub 2. Okay. Next. So it complies with the rule 3. Next is x sub 3. Okay. Z sub 2 must intersect with x sub 3 based on rule 3. So if we extend z sub 2, yes, it is intersecting with x sub 3. Okay. So our x-axis, all our x-axis are complying with rule 3. So let's go to the last rule, rule 4. All frames must follow the right hand rule. So rule 4 is all about the y-axis. Okay? So the right hand rule is this. Okay. So right hand rule, the z-axis is the thumb. The x-axis is the what do you call this finger? The pointing finger. And y-axis is the middle finger. Okay. So based on the right hand rule, you will draw the y-axis, okay, in your kinematic diagram based on the direction of your middle finger. So for example, in this frame 0, okay, z sub 0 is the thumb, x sub 0 is the pointing finger or the index finger. So because we are using the right hand here, the direction of the y-axis is backward. Okay, you may try this and see if it is pointing backward. Okay, so this is backward. Again, we will draw the front and the back like this. It's like 45 degrees from the first two axes. But in reality, this is perpendicular to the first two axes. Okay, so this is y sub 0. Next, For the frame 1, the z-axis is the thumb, the x-axis is the index. So the middle finger, if you try this, is pointing backward. Okay. So this will be y sub 1. Okay, next frame. Next frame is different from the first and second frame. So frame 2. Okay, so this is axis. This is the thumb. This is x-axis. So the middle finger is pointing downward. Okay, pointing downward. Okay, so this will be our y sub 2. The our y sub 2. Then last for our end effector. Okay, the end effector. Let's also use the rule 4. The x-axis is pointing to the right. Y-axis is pointing to the front. So the y-axis is pointing to the bottom. Okay, to the ground. Okay, so this will be our y3. Okay, y3. If you notice, class, the y-axis is thinner, thinner arrow, and smaller because based from the preliminary rule, the y-axis is the least important axis. We don't actually we don't need it for our future computations. It's just there to complete the Cartesian coordinate systems or the frames, the XYZ frames. Okay. So this is the kinematic diagram of a cylindrical manipulator. So I hope you understand and try to practice the frame assignments for the cylindrical manipulator. So for the next video or the next series of these videos, I will also do the frame assignments for the spherical manipulator, articulated manipulator, Scara manipulator, and Cartesian manipulator. Okay.